So the next thing that we did on our Rube Goldberg machine is force and motion. And so what we did for this is we had a bouncy ball resting on the very edge of a flat wooden ramp, and we had the marble that was doing the projectile motion previously, and it lands on a flat wooden surface and it continues to roll, and it knocks the bouncy ball off the edge of a board. And so the bouncy ball is our system, and we're doing calculations on the force of the marble acting on the bouncy ball. And so our bouncy ball weighs 0.0117 kilograms, and our marble weighs 0.005 kilograms again. And so what we did is we had to calculate the impact time, which was kind of hard to do, but we got 0.1 seconds. And then we did our calculations. And so also for the marble, when the marble, we can borrow the velocity that the marble was traveling at and use that in our calculations, because when the marble traveled off the board for the projectile motion and when it landed, it should be rolling at the same velocity that it went off the board. So we just borrowed that from the earlier part. And so next we did our calculations, and we calculated the marble's acceleration upon impact, and we used the impact time and the change in velocity. And so we got negative 10.9 meters per second squared, and then we plugged that into Newton's second law with the mass of the marble, and then we got 0.0545, and it was negative, and we can change it to positive because the force is being applied to the right. So that means it's positive. And so next we calculated the magnitude and direction of the summation of forces acting on the bouncy ball. And so we took the equation force equals force of N plus force of gravity plus the force acting horizontally on the ball. And so in this case that is 0.0545 newtons to the right. And so force of N and force of gravity cancel each other out, so then that's just our answer, 0.0545 newtons to the right. And that's the summation of the forces. And so next we calculate the magnitude and direction of the bouncy ball's acceleration after impact. So basically how fast the bouncy ball is flying off the board. And so we use Newton's second law again, force equals mass times acceleration. And we get, we're solving for acceleration this time, so we do 0.0545 newtons equals the mass, which is 0.0117 kilograms of the bouncy ball. And then we solve for acceleration. And so the acceleration that it flies off the board is 4.658 meters per second squared. And those are calculations. And then for the force diagrams, what we did, I did two force diagrams. And then, so we did the force of the marble acting on the bouncy ball and the force of the bouncy ball acting on the marble. And so the force of the marble acting on the bouncy ball, for Fn and Fg, it's just basically it's just the weight of the marble converted to newtons, and then you do a positive for Fn, and force of gravity is negative, and then you do we calculated the force that it was applying on the marble to the right already, and that's 0.0545 newtons. And then for the bouncy ball, you basically do the same thing, convert its weight to newtons, and then that's the Fn, and the negative of that is force of gravity. And then the force that it's applying on the marble is negative 0.0545 newtons because of Newton's third law. So that's the force of A acting on B equals a negative force of B acting on A. And that's for impact. They exert the same amount of force on each other. And so that's it.